Good morning, this is Mrs. Groves. Today we're covering section 6.7, graphing linear inequalities with two variables. Make sure you have that handout ready. Now we need to review a few things about inequalities before we start to graph them. First, let's remember when we were graphing inequalities, there was one rule that we always had to remember to do. Why don't you think about that? You got it? The rule is for inequalities, you must switch the symbol when you multiply or divide the variable by a negative number. This is also true when we go to graph them. So, I'm going to give you a little bit of an overview as to what we're going to do. So, linear inequalities in two variables are the same as linear equations. But they have inequality symbols. Less than, equal to, greater than or equal to. So if I asked you to graph this line, y equals 1/2 x plus 4, you know how to do that. Okay, so I want you to sketch a little graph here on the side. And hopefully you remember the Y-intercept is 4. The slope is 1/2. So we're just sketching this little graph, 1, 2, 3. There's the Y-intercept. We go up 1, over 2, up 1, over 2, and then we draw our line. Now, if you don't have rulers at this time, why don't you just pause this video, get your rulers, because you're going to be graphing these inequalities. So now do you have your rulers? So the difference between graphing an equation and graphing an inequality, and we're going to get into a lot more detail about this, is that we have an inequality symbol. And if we pick a point, say 2, 3, which is below this line, and we plug in the x coordinate, 1/2 of 2 is 1, plus 4 is 5, and y is 3. 3 less than 5. This is a solution. If we plugged in the origin 0, 0, 0 is less than 4. That's the origin. So that means that our solutions are all the solutions that are below this line. So, the graph of an inequality in two variables is an example like this one. You graph the linear equation like you normally would, and shade the side that will be all of your solutions. So in this example, everything that is below this line are solutions to this inequality. Alright, so let's go on to example 1. Example 1 is having us determine for this linear inequality how do we determine if they are solutions? And you've done this before. You have an ordered pair. You want to find out if 2, 0 is a solution to this linear inequality. There's your x coordinate, there's your y coordinate. So we're going to substitute 2 for x, so 3 times 2. And we're going to substitute 0 for y, minus 4 times 0 is greater than 9. We simplify it, and we get 6 is greater than 9. Now then you ask yourself, is this true or false? This is false. Since it's false, the ordered pair 2, 0 is not a solution. Alright, so the next one we're going to try is the point 2, negative 1 a solution to this linear inequality? For x, we're going to replace it with 2, so 3 times 2. For y, we're going to replace it with negative 1, minus 4 times negative 1 is greater than 9. So 3 times 2 is 6. Negative 4 times negative 1 is 4, greater than 9. 10 is greater than 9. You ask yourself, is this true or is this false? This is true. Since it's true, this point right here is a solution. Now I'd like you to add C. Test the origin, which is 0, 0. we're going to learn when we are graphing these inequalities, the easiest point for us to test is the origin, 0, 0. So what I want you to do is I want you to check, plug in 0, 0 into this inequality. And you're going to get 3 times 0 minus 4 times 0 is greater than 9. See how easy 0 is? What's the left-hand side, everyone? 0 is greater than 9. You ask yourself, is that true or is that false? That is false. So the origin is not a solution to this inequality. Alright, you might want to pause the video for a moment. Make sure you have all these notes before we go to the next page. We're now on the second page of the 6.7 notes, and before I go over those on how to graph a linear inequality in two variables, I want to review the 3 methods that we have learned on how to graph linear equations. We are going to be graphing until February break. So I'm going to take the opportunity in this section of notes to go over our 3 methods of graphing. We have create a table, graph using y equals mx plus b, and if the equation is standard form, graph with x and y intercepts. Now, at this point, you can use any method that you want to graph these lines. So whichever one you're the most comfortable with, that's the one you want to do. So just as a review for tables, you create a table. Now you get to pick the x values. The easiest x values to pick are -1, 0, and 1. You plug in these x values into your equation, you get your y values, and those ordered pairs are the ones you plot on your graph. Now remember, it's hard to plot fractions. So, if you get an equation that has a fraction, then take that fraction and use multiples of the denominator. So the easiest ones are going to be to take -3, 0, and 3 in this case. 0 is always going to be your easiest number to graph. So you would want to use 3 and -3 as well. So that's creating the table. Now, if you want to graph using y equals mx plus b, which is probably the one that you're going to do the most often, you have to remember that m is slope, b is y-intercept. And the first thing that you plot is going to be the y-intercept, which has the coordinates 0, b. Then you're going to use slope, m, to find additional points. Alright? And because we're graphing, you're going to use slope with rise over run. Now, if the equation is in standard form, remember ax plus by equals c, the easiest method for graphing is going to be to use x and y intercepts. So let's take an example here. We have 5x minus 2y equals 10. And that's in standard form. And I'm going to have my graph, x and y. And the first thing I want to do is I'll find the x-intercept. The x-intercept is going to be on the x-axis, so y is going to be 0. So remember the cover method. Cover that. 5 times what gives me 10? 5 times 2, so the x-intercept is 2. Okay, so that's at 2. The ordered pair is going to be 2, 0. Then I want to find the y-intercept. And the y-intercept means that x is going to be 0 because it's on the x-axis. So what number can I put in for y? I can put in the number -5 because -2 times -5 is 10. So my y-intercept is at -5. It has the ordered pair 0, -5. Now I have 2 points. And so now I can draw my line. So that is a review of the 3 methods to graph. And you can use any method that you wish to graph. So now we're going to learn how to graph inequalities. Okay. We're going to learn how to graph linear inequalities. And there's basically 3 steps. Okay. And what we're going to do is we're going to go through each of these steps and we're going to graph this inequality. So step 1 says to graph the boundary line. So the boundary line is basically just graphing the equation y equals -1/2 x plus 4. All right. So if we want to graph that, our slope is -1/2. And it better look graph line like that, and our y-intercept is 4. Now, with inequalities, we have one more thing that we have to take care of. We have to take care of the symbol. And since this symbol is less than, graph the boundary line. We're going to graph this line, which on this graph down here, the y-intercept is at 4. I go up 1, back 2, down 1, over 2, okay, down 1, over 2. But I don't want you to draw the line yet. So that is graphing our line. But This is an inequality. So something special happens. Since it is less than or equal to, we use a dotted line. So the inequality is less than, so use a dotted line. And so when I graph this, okay, it's a dotted line. Now, we would use a solid line if we had the equal sign. But since it's got the less than, we're going to have a dotted line. So that's step one. We just graph a line. And then we have to figure out, is the line solid or is the line dotted? Our next question is, what side do we shade? Okay. So we test a point not on the line by checking whether the ordered pair is a solution of the inequality. And the easiest point to test is 0, 0. So you're going to test 0, 0. Right? So just make yourself a note. Use 0, 0 to test which side to shade. So now this is step 2. We test 0, 0. So for y we put in 0, less than negative 1/2. For x we put in 0, plus 4. We get 0 is less than 4. Is that true? It certainly is true. So that tells us zero, 0 is a solution. Which now brings us to step 3. Step 3 says, shade the half plane. Which is a fancy word for saying shade the side. Containing the point if the ordered pair is a solution of the inequality. So in this case, this point is a solution. So we are going to shade the half point that contains zero, 0, because 0, 0 is a solution. So we shade the bottom half. Now the question is, what are the solutions? Okay. Well, 1, 0, 0 is a solution. We've tested that. 2, all the points which are x, y coordinates below the line are solutions. And finally, you have to ask yourself, are the points on this line solutions? What do you think? Are they solutions or not solutions? It's a dotted line. 3. Since it is a dotted line, the points on the line are not solutions. So, you might want to pause. Oh, we forgot to fill in something up here. Now, in our case, we found that the ordered pair, our origin was a solution. So we shaded the bottom half. If this was false, okay, we would shade the other half plane if the ordered pair is not a solution. So these are the notes for the top of the page. You might want to hit pause if you need to. And then these are the notes for example 2. Well, I'm back, and now we're on example 3. And before I get into example 3, I want to review horizontal lines and vertical lines. All right. So, example. Every horizontal line is going to be y equals the y-intercept. So if we have a graph x and y, and we have the example y equals 5, okay, that means that the slope is 0 because there's no x term, and the y-intercept is 5. So the Y-intercept is up here, and that's at 5. And it's going to be a horizontal line. Now, if you get yourself confused, just kind of do a little chart, X and Y. The Y is always 5. So -1, 0, and 1. So -1, 5, 0, -1, 5, 0, 5, 1, 5. So that's one good way to make sure, just with this simple little table, that you draw a horizontal line correctly. A vertical line is always going to be X equals the X intercept. A equals the X intercept. So, if we take the example, X equals 2, we can draw our graph, and here we have our x-axis, our y-axis, and here X is at 2. And this is going to be a vertical line. And again, you can double check it with the little table X and Y. X is always 2. Pick any numbers you want for Y. Okay, so 2, -1, 2, 0, 2, 1. Okay. So that's a review of horizontal lines and vertical lines. And I did that because we now want to graph the inequality X is greater than or equal to 4. And we're going to go through the same process we did as the prior example. Alright. It says graph the equation X equals 4. Now we have to figure out, are we going to use a dotted or are we going to use a solid line? Okay? For greater than equal to and less than or equal to, we use a solid line. So, okay. And the graph of it is, okay, the x-intercept is at 4, and here is the vertical line. Okay, it's a solid line. And I'm going to tell you not to test. The easiest point to always test is 0, 0. Here's your origin. Okay, so if I go through, you only have to substitute the x coordinate because the inequality does not have the variable y. So for x greater than or equal to 4, I substitute in 0, 0 greater than or equal to 4. Is that true? No, that is false. Therefore, this is not a solution. Okay, so we can fill this in here, 0. So we took our test point of 0, 0. Alright. Okay. 0 is greater than or equal to 4. It's false. So that means that we shade the other side. Okay. We're going to shade the half plane that does not contain 0, 0, because 0, 0 is not a solution of the inequality. So here was an example of a vertical line. Now I want you to do this one yourself. This is going to be a horizontal line. So I'd like you to pause and do this problem. Now I know this is going to be a horizontal line because its y is less than 2. So my y-intercept is here. You ask yourself, is it dotted or is it solid? It's going to be dotted, okay, because there's no equals. And then you have to figure out which side am I going to shade. So we pick our test point, 0, 0. Right? And 0 is less than 2. That's true. So this is a solution, and I shade the bottom. Now we have to do example number 1. Alright. And in example number 1, okay, you ask yourself, what's going to be the easiest way to graph this? And the easiest way to graph this is going to be by using X and Y-intercepts. So if I want to find the X-intercept, remember, I'm going to set that y to 0 and x is equal to 2. So the x-intercept's at 2. Now to find the y-intercept, I'm going to set that equal to 0. So the y-intercept is 4. So the y-intercept is at 4. Because this is an equals, that means I'm going to have a solid line. Here it was a dotted line. So now I draw the line. You could have put it in slope-intercept form, but that would have been a lot more work. And now you take a point, and the easiest one is to test 0, 0. So if I plug in 0 here, I get 0. If I plug in 0 there, I get 0. So 0 is greater than or equal to 8. Okay, which is false. So this is not a solution. So I shade the top half. Okay. So I graphed my line. I found my X and Y intercepts. I picked the origin because that's the easiest point to test. I test 0, 0. Since 0 greater than 8 is false, this is not a solution. I shade the other side. Okay, so make sure you have all of your notes. There's the top half. There's the bottom half. You might want to hit pause. And then I'll go over. So let's take a moment to look at your Chapter 7 assignment page. And your homework tonight is to complete these notes. The back page has several problems that you have to do. And to do this assignment, and you'll need graph paper. So what I'd like to do now, that you know what your homework is go to the back and do a few of these examples with you to make sure that you are all set with solving linear inequalities. Now I want to make sure that you know how to do these problems. So it says tell whether the ordered pair is a solution of the inequality. So I'm sure you're not going to have any trouble with number 1. So let's do number 3. We're going to take the x value, 2 times negative 6, minus, and we're going to put the y value in parentheses, greater than 4. For this standard, you're going to have to be able to determine what points are solutions and what points are not solutions. So make sure you know how to show your work correctly. So this is going to be negative 12 plus 15 is greater than 4. 3 is greater than 4. You say to yourself, is this true or is this false? And it is false. If it's false, what does that mean? It means that negative 6, negative 15 is not a solution. Okay. So what I'd like to do is number 13 with you and number 15. Because 13 is going to be pretty easy. Right? I'm going to put this into y equals mx plus b. Now to do that, all I have to do is divide this by 4, and divide that by 4. And 4 divided by 4 is 1. So I'm going to get y, okay, less than or equal to 6 over 4 reduces to 3 over 2x. 12 divided by 4 minus 3. So the y-intercept is at negative 3. My slope is 3 over 2, and it better look like that because that's a positive slope. Up 1, 2, 3 over 2. And then you have to decide, is this going to be a solid line or a dotted line? Because it has the equals, it's going to be solid. Okay, so this line is solid. I now want to test 0, 0, because that's such an easy point to test. In the original inequality. So if I put in 0 here, 4 times 0 is 0, less than or equal to. 6 times 0 is 0, minus 12. 0 less than or equal to negative 12 is false. The origin is not a solution, so I shade this side. Now, this one is a very good one to review. Number 15. I have negative 6x plus 6 greater than or equal to negative 18x. Again, I want into y equals mx plus b. I subtract 6 from both sides. I get negative 6y is greater than or equal to negative 18x minus 6. And then I have to remember to do something. I'm dividing the variable by negative 6. The variable is divided by a negative number, so I must switch the inequality symbol. So y is less than or equal to 3x plus 1. Okay, and I think you're going to need extra room for this problem, so I would just kind of make sure that I had enough room to work this problem out. My slope is going to be 3 over 1. My y-intercept is going to be 1. So here's my y-intercept. I go up 3, 1, 2, 3 over 1. I go down 3, 1, 2, 3, back 1. And because I have an equals, this is a solid line. I draw the line. And then I want to test 0, 0. And I want you to show this step. You're going to test 0, 0. If I plug in 0, on the left-hand side, what do we get? We get 6. On the right-hand side, what do we get? We get greater than or equal to 0. That is true. Because that's true, we shade this side. So for the rest of the period, work on these problems. The answers to these problems are posted on my website in the 6.7 notes. And don't forget to do your homework on graph paper. And have a nice rest of your day from Mrs. Grove's home to you at school.